three-phase transformers. Under three-phase transformers, we're studying the construction features of a three-phase transformer, choice between the single unit three-phase transformer versus bank of three-phase single-phase transformer, their advantages and disadvantages, and the transformer connections uh, for three-phase operation, that is star 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 delta zigzag star VB connection, comparison of these connections as well as the Scott connection converting two phase into three phase and vice versa. Start with the transformer. We know that whatever the electricity we are getting is the generated, transmitted and distributed in the three-phase manner. Means the almost all major generation, distribution, including the transmission system in the world are three-phase system. Three-phase transformers play an important role in this system. That is, the three-phase the transformer has got a major role in the transmission as well as the distribution of the electric power. For reasons of why they are using this three-phase transformer, because of efficiency and considerable economy in the use of the copper, the generation and distribution of electrical power takes place on the three-phase basis rather than the single phase. Therefore, that is the system is a three-phase. Therefore, the essential part of the power system is a three-phase transformer. In a three-phase generation, transmission, and the distribution, the transformers are used in a three-phase mode to provide required the transformation. That is, in the case of the transmission level, it is stepping up the voltage. In the distribution level, it is stepping down the voltages. Means, as per the requirement of the system, one should have a three-phase transformer in the different parts of the power system. Then the transformer for a three-phase circuit is either we have to use two different mode of construction. One is one single unit of a three-phase transformer, or you have to make use of three single-phase transformer. They are connecting for the transformer banks. These are the two options before the user. That is, a three-phase transformer can be constructed either by connecting together three single phase transformers. If you have got a single phase transformer, they are connecting in different modes, either star star, delta delta, star delta, delta star, anything. Means here the three transformer involved to make it a three phase transformer. Means a three single phase transformers, thereby forming a so-called three phase transformer bank. And the second option is employ a common core for three sets of winding of the three phases. Means you have to construct three core, three phase transformer. Then if you are going for a three phase, a single unit construction, the construction of a single three phase transformer is preferred today. It is because it is a lighter, smaller, cheaper and slightly more efficient. That is, if you are making only one unit of a three-phase transformer, then has got a lesser cost, it is a lighter and it is smaller. At the same time, it is more efficient than the three single-phase transformer bank. At the same time, there is an advantage that each unit in the bank could be replaced individually in the event of a fault. That is a major advantage of the single units which is connecting for three-phase connections, is that anything happens in the one of the transformer, that can be easily transferred and there is a continuity of the supply. But in the case of a single unit, if anything happens, that is whole system is the setup. Okay, that is one disadvantage of a single unit of a three-phase transformer. But in the case of, there is an advantage that each unit in the bank could be replaced individually in the event of a fault, However, this does not outweigh the other advantage of combined three-phase unit. Other than this, they have got, the single unit has got the other advantages. Some of the advantages I am listing out here using a three-phase transformer or a bank of three single-phase transformers. One is the cost of a three-phase transformer is about 15% less than a bank of three units of single-phase transformer. If you are using a three single-phase transformer for three-phase connections, then it is a costlier than a single unit of a three-phase transformer. That is, one is a three-phase transformer is it is the less cost as compared to single-phase transformer bank for three-phase connection. That is one. That is economy. The second advantage is that it occupies less space. That is, if you are using three individual single-phase transformer, it is occupying more space, whereas the single unit of three-phase transformer occupying the lesser space. At the same time, weight of a single three-phase transformer, that is one unit of a three-phase single-phase transformer, is less than that of three-phase single-phase transformers. That is, the weight is also very less. The space required is less, as well as the weight is less. Also, it is cheaper than a three single-phase units. And the fourth advantage is that it is easy to install a single three-phase transformer rather than the bank of three single-phase transformers. The construction features. A three-phase transformer can be constructed by having three primary and three secondary windings on a common magnetic core. Once again, we have got the core type and cell type of the transformer in the three-phase also. Then these three-phase windings are wound on the magnetic core. The three single-phase core type transformer, each with winding primary and secondary. In each core, we have got both primary and secondary winding. On only one leg, have their unwound legs combined to provide a path for the returning flux. That is, what I mean is, that is, if you are taking the core of a transformer, in that case, in only one limb, you wound both primary and the secondary. Then the one limb is left out, that is used as path for the returning flux is what he means. At the same time, the primaries as well as secondary may be connected in either star or delta. That is, each winding they are connecting, they are the terminals are brought out, they are connecting either in the star or a delta for as per the requirement. If the primary is energized, that is, if you are giving a supply to the primary winding of a from a three-phase supply, the central limb, that is unwound limb, carries the flux produced by the three-phase primary windings. That is, we know that the one limb is kept free, so that carries the flux produced by the three-phase primary windings, all the three-phase windings. I will show you the figure. Since the phasor sum of a three-phase current at any instant is 0, we know that sum of the balanced three-phase currents is 0. Therefore, the sum of three fluxes passing through the central limb must also be 0. Hence, the no flux exists in the central limb and it may be therefore eliminated. Therefore, central limb may be eliminated so that we have got only the three limbs. This modification gives a three-leg core type three-phase transformer. Before, what I told you, that is one limb is kept free for the return path. But if you are using for a three-phase connections, the sum of the currents, the balanced current which is fed by the three-phase supply to the primary winding, which is producing the flux, if the currents, the sum of the currents IA plus IB plus IC, that is a factor sum is equal to 0, then the total resultant flux producing by IA, IB, IC is also 0. Therefore, this modifies gives a three-leg core type three-phase transformer. In this case, any two legs will act as a return path for the flux in the third leg. Then how there is a return path? Then what is telling that in this case, any two legs will act as return path for the flux in the third leg. That is, if we are considering a third leg, the return path for the third leg is 1 and 2. For first leg, the return path is second and third, like that. For example, if the flux is phi in the one leg and some at any instant, then flux pi by 2 in the opposite direction through the other two limbs at the same time. That is, if there is a flux is producing phi in one limb, then phi by 2 which is producing by the other two limbs in the opposite direction. All the connection of the three-phase transformers are made inside the case, and for delta connected winding, 3 LEDs are brought out, while for star connection winding, 4 LEDs are brought out. Means whenever there is star and delta connections, then for a delta connection you are bringing out only 3 terminals. However, for a star connection you are bringing 4, 1 for a neutral, 3 for the 3 different phases. This is a core type of the transformer. What I mean is, this is how we are reducing. That is, this is a common limb, but at any instant of time, the current IA plus IB plus IC is equal to 0. At the same time, the flux is also 0. Therefore, it can be eliminated. Therefore, you can modify the core type of transformer with only 3 limbs instead of 4 limbs. There is 1, 2, and 3 and 4 is a common limb, but the flux or a current which is flowing here in the common limb is 0, or a flux is 0. Therefore, that can be eliminated. Therefore, we have got only the 3 limbs on which both you have wound the primary as well as the secondary windings. Consider a 3 single phase core type transformer positioned at 120-degree electrical to each other as shown in the figure. Okay, there is 3 windings are wound on 3 with 120 apart. If the balanced 3-phase sinusoidal voltage are applied to the windings, then flux phi A, phi B and phi C will also be sinusoidal and balanced. If you are applying a balanced 3-phase supply, then the flux produced by IA, IB, IC is phi A, phi B, phi C. Those are also sinusoidal in the nature, and they are also the balanced one. If the 3 legs carrying these fluxes are combined, and the total flux in the merged leg become 0. I told you that if at any instant of time the sum of all the 3 currents at any instant of time is 0, therefore the flux is also 0. This leg can therefore be removed because it is carrying no flux. That is, can be removed, and you have to have only the 3 limbs. This structure is not a convenient for the core. The core of the 3-phase transformer usually made of 3 limbs on the same plane. I told you that is the second plane. This is you have to make it like this on the construction. In the same plane you have to place all the 3 limbs, and you have to wound both primary and secondary on that. This can be built using the stack of laminations to reduce the hysteresis and eddy current losses. Each leg of the core carries low voltage as well as high voltage winding. Means each limb you have got both primary and the secondary windings. The low voltage windings are insulated from the core, then the high voltage is winding. That is, usually the low voltage winding, either it may be primary or a secondary, it is wound here to the core, and on which we are wound the high voltage winding. The high voltage winding are placed over the low voltage winding with a suitable insulation between them. The magnetic path of the leg A and C is greater than the leg B. The construction is not symmetrical, and there is a resultant imbalance in the magnetic current. That I will analyze using the vector diagram in the subsequent topic. Then in the cell type of a transformer can look into here, that is both the primary and secondary of each phase are wound on a common central limb, and other 2 limbs act as a return path. Other 2 are as a return path. That is, the cell type 3-phase transformer can constructed by stacking 3 single phase cell transformer as shown in the figure. That is, the winding direction of this central unit B is made of opposite to that of units A and C. That is, if it is one is taken as the excited, in that case the other two as acting as a retrograde. If the system is balanced with a phase sequence of ABC, the flux will also be the balanced. The magnitude of these combined flux is equal to the magnitude of each of its component at any given time. The cross-section area of the combined yoke is same as that of the outer leg and top and bottom section of the yoke. The imbalance in the magnetic path has very little effect on the performance of the three-phase cell type transformer, and the winding of the cell type three-phase transformer are either connected in delta or star as per the requirement. These are the some of the pictorial views of the core type and cell type of the transformer. Okay, this is the your core type transformer. It is first there is a low voltage winding wound. On that there is a layer of the insulation. Over that they have got a HV winding. You can see here it is a core type of a transformer, and the central limb you have got the three windings, that is on first once again LV winding and IH winding. Okay, that is primary and secondary windings. This is how a three phase or single unit is looks like. It is a single unit of a three phase transformer, whereas in the construction manner, this is how I explained the the common core or limb can be eliminated. Instead of that, we are making the two winding on the same limb. Some of the disadvantages of a three-phase transformer or a bank of a three-phase single-phase transformer. We seen at the earlier the advantages of the single unit of a three-phase transformer, but there are some disadvantages of a three-phase transformer over the bank of three single-phase transformer. That is, one is the transformation of the three-phase transformer is difficult. The transportation of a three-phase transformer is very difficult because it is a bigger unit, so that in the remote places where there is a would install for especially for the transmission purposes, that is the power stations are situated in the very remote places, not proper connectivity to the power plant, nearer to the power plant. In that case, heavy unit of a single unit transportation is very difficult. In case of a failure of the transformer, whole supply system will be collapsed. That is another major disadvantage of a single unit of a three-phase transformer. These are the three-phase voltage and current ratios that I will take up in the next section.